Right, in this video we're going to be taking a look at how to solve a complicated circuit in terms of it's a parallel with a series built inside it. We're going to solve it in terms of V, I and R for each one of those resistors. So the first step we take is we work out our total voltage, which is 6 volts, which is already given to us. So VT is actually 6 volts. We want to work out our total resistance, and then therefore we can get our total current inside this circuit. So the total resistance then, what we have here is we've got a series, 2 resistors in series and one on its own, and this is in parallel with this over here. So what we do is we add those two up, so 3 ohms plus 10 ohms is going to give us that system there, which is going to be 13 ohms. So that's the total resistance for the bottom two. And then what we do is we treat this as a parallel system. So that's not actually the total resistance at the moment. We need to actually treat it like it's a parallel circuit. So RT is equal to 1 over 13 plus 1 over 4. So the 13 is a combination of those two, and then the 4 just comes from there. So total resistance for this circuit is actually going to be 3.06 ohms. That's the total resistance. And then to work out the total current, all we need to do is VT divided by IT is going to give us is going to give us IT. So the total current there is 6, so total voltage is 6 divided by 3, the answer we just got, and we get an answer of 1.96 amps. So that's our total current, which is being forced out of this cell over here. So if you were to put an ammeter, let's just say over here, that's what the ammeter will read. It would read 1.96, and over here it would read exactly the same, 1.96 amps. So what we need to do is we need to find out how much current goes to that one and how much current goes over here. So current always takes a path of least resistance. So it can either go down the 4 amp route, or it can either go down the 13 amp route. So this 13 ohm route, is going to slow it down quite a bit. So most of the current we're going to expect to go through there, a small amount of it will go through over here. So that's what we're going to try and determine now.